Hello everyone, welcome back. Hope you had a good weekend. We'll be starting this week off with learning about introduction to integrals, and we'll be starting with the basic example of just integrating x from the lower bound of 0 to the upper bound of 3. So that might have just seemed like a lot of new words to you, might not know half of what I just said, but we'll be starting with basic with what is an integral. So an integral is the opposite of what we learned last week, in that it is essentially the opposite of differentiation. Instead of finding the slope of a function, as we did last week, it's essentially finding the area under a curve. So what does this mean? That means if we graph the function here on a basic y-x plane, we want to graph this function x from the lower bound of 0 to the upper bound of 3. We have 1, 2, 3. 1, 2, 3. We're going to graph this. Just do a different color. So just use our basic algebra skills and graph it like that. And then we eventually want to find what we call the area under the curve is this triangle region right here. So we don't even need a calculus to be able to solve what this integral is. We can just solve it by just knowing what the area of the triangle is, right? So let's just do this for purposes of learning. So we have 1/2 times the base, which is 3, times the height, which is 3, and that's 4.5. So then let's just use that as a cross-check when we actually do the math. So how to set this up? So we have this weird squiggly line initially that indicates that we're going to be taking the integral of something. Then when it has definite bounds, we would just set them for the lower bound at the bottom here and the upper bound at the top there. Then we put the function that we're integrating to the right of it, essentially inside of the integral. And then we have this extra tag at the end here, dx, or d times whatever other variable we're integrating with respect of. And that's just telling you which variable we're interested in integrating with respect to. So from here, it doesn't really matter because clearly it would be the x. But sometimes it's more prevalent if we have like x times y or x times y times v squared, and we want to know what specific variable we should be finding the area underneath. Now, how to solve this is pretty simple, actually. So we have our 0 to 3, x dx. So we're thinking the opposite of differentiation. So differentiation, if you remember from last week, we would take the exponent of whatever variable we had, and we would subtract 1 and then bring down the current exponent to the base. Here we would do the opposite. So we have a 1 on the exponent there, so it's imaginary, or we don't really write it out. And here we were, instead of subtracting 1 as we would in differentiation, we add 1. So we have 2. And then we multiply the entire function by the inverse of the exponent that we now have. So the inverse of 2 is 1/2. And then we want to evaluate this from 3 to 0. So we actually take the integral, the squiggly line is replaced with this bracket here. And then we can just compute it as normal. And then we get 9/2 equals 4.5, which checks out from above. And then as kind of a cross check, we can take the integral we just solved, and we can make sure that that was correct by actually differentiating this and seeing if we get back our original function that was inside of the integral. If we differentiate this, as we learned last week, we take the exponent down here, so it's 2 times 1/2. And then we take the exponent that we have and subtract it by 1. So we get 1 times x to the 1, and that is x, and that is what we had originally. So that is a basic introduction to integrals. Obviously, this will get a lot more complicated as we deal with more complicated functions with exponents and logarithmic functions and polynomials. And we'll learn some more tricks and things that we can do with that. But for now, if you have any questions, please let me know and I'll be happy to answer them. Thank you.